Welcome to Kaleido, the full-stack cloud platform for consortia blockchain networks. Kaleido supports both Microsoft Azure and AWS, allowing for multi-cloud, multi-region, borderless blockchain orchestrations. Let's take a look at how Kaleido works. Now, if you don't have a Kaleido organization, it's very straightforward to create one. Simply provide some high-level details and choose a geography where you'd like your details to be stored, and in a matter of minutes, you can have your very own Kaleido org. I already have one, so I'll go ahead and sign into the console. Now, the first prompt upon logging in is to create a consortium. And a consortium is a grouping of the memberships and orgs that are going to participate in your blockchain network. Let's say we want to create a consortium for healthcare provider data. We can create the name and optionally supply the mission. Share and exchange healthcare provider data. And now we want to set the home region. The home region is where the metadata, membership details, etc. will be stored. And we can choose between AWS and Microsoft Azure as our home region. Let's go ahead and choose AWS as the home region. And now we can proceed to whitelist additional deployment regions. Any whitelisted deployment regions will be able to host blockchain environments, host nodes, host Kaleido resources. So we can whitelist Azure in Washington and AWS in Europe. And these regions can be enabled after the fact. This doesn't all have to be done at this point. Click Finish, and we'll have the baseline scaffolding for our consortia. Now, upon creating your consortium, the first call to action will be to introduce or to identify yourself. And this modal allows you to upload a digital X509 certificate and underpin your asserted identity with that certificate. So this common scheme of PKI is used everywhere with client-server authentication, and Kaleido allows you to do this in an off-chain fashion as well. So we can bind our healthcare provider membership with a digital X509 certificate. And now the rest of the network will be able to download and inspect that certificate and make sure that it's been signed by a reputable root certificate authority. And this accommodates for KYC concerns and allows organizations to be authoritatively identified by the rest of the network. Okay. So we have our baseline scaffolding for the consortia, and we can proceed to build it out in one of two ways. If we want to leave this as a centralized consortia, we can add multiple memberships that will all be bound to the founding consortia operator. So if we create multiple memberships, they will have a one-to-one correlation with this organization. Alternatively, we can create a decentralized consortia by onboarding external organizations. Now, when onboarding an external organization, you as the system administrator, the founder, have the ability to allocate or rescind admin level permissions. And there are 4 high-level permissions. The ability to create nodes that will participate as signers or validators in the consensus algorithm, the ability to manage environments, the ability to subsequently onboard other external organizations, and the ability to create multiple memberships for your own Kaleido organization. One important feature with Kaleido governance and permissioning is this notion of inherited governance. So you yourself can only extend permissions that you actually have. If we onboarded provider XYZ with these permissions, they could subsequently invite fellow organizations, but they could not extend the permission to manage environments to those invited organizations. Nested and inherited. We can send the invitation, and this system administrator will be able to inspect that invitation, see the existing orgs and memberships, and accept or decline accordingly. Great. Now we can proceed to create our first environment. And environments in Kaleido are isolated domains. They're their own instances of the blockchain with resources and nodes confined solely to the environment. We can provide a name for our environment. Let's call it development. And now we can choose the deployment region. And the available regions will be whichever clouds and underlying availability zones we've whitelisted. So we see that we have US East, EU, and Microsoft Azure West. So we can choose AWS as our region. In the near future, you'll have the ability to create multi-region environments and have resources exist and function compatibly across different cloud providers and across different availability zones. So we can have a node running in AWS in Columbus, Ohio, and that will be compatible with a node running in Paris on Microsoft Azure. We can click Next, and now we can configure our environment. And one unique feature of Kaleido is the ability to create bespoke environments. And we see we have choices between different node clients and different consensus algorithms. The first option is Geth, the Go implementation of the Ethereum node, and proof of authority consensus. The other option is the Quorum Client. Quorum provides capabilities for private transaction processing and confidential transactions through what's called the Constellation. It has a transaction manager and an enclave for crypto operations. Quorum offers you IBFT consensus, Istanbul Byzantine fault tolerance, and Raft, which is a very high-speed implementation, low latency, immediate block finality. We have extensive documentation helping you decide what the right choice is for you based on security and based on performance mandates. Let's choose Geth and POA. We can click Finish, and now we've created our environment. We've created this namespace, and we want to proceed to fill it out with nodes. So let's create our first node. Call it Node 1. And if we created multiple memberships against healthcare provider ABC, we would be able to bind this node to any of the memberships under our control. Click Next, and now we can optionally integrate with existing native cloud services. So we'll see a suite of AWS services. If we had chosen Microsoft Azure, we would see a similar array of Microsoft Azure cloud services. There's 4 high-level services you can choose to integrate with. KMS for extended security on the node's file system, using a master encryption key to turn the entirety of the file system into ciphertext. Log streaming, allowing you to pump your Geth or Quorum logs into a CloudWatch logging group. This allows you to build powerful analytic Cabana dashboards where you can marry your existing applications and business processes against the actual blockchain logs. Very, very useful for diagnosing problems or optimizing current applications. The third is the ability to back up the entirety of your node's file system. So all of the ledger and all of the important signing key material. This will go to an S3 bucket in Amazon. So this gives you the full blockchain and anything you need to sign with for consensus or for peer-to-peer validation or for user accounts. And the last one is the ability to send network traffic, send communication streams as you see fit. If you have highly confidential data, there may be the chance that you don't want to send that over the public internet. So every Kaleido node optionally comes with a private ingress, and using a service such as AWS Private Link in conjunction with a virtual private cloud allows you to keep that traffic solely on the AWS backbone. So you can grab and choose any of these services that you need. Go ahead and click Next. And lastly, you want to configure your node with a size and a role. And the size has a 1-to-1 correlation with certain performance metrics and underlying requests per second and allowed concurrent connections. We have very extensive documentation talking about these metrics. So based on your expected throughput and performance you need, you can make the appropriate decision. Choose whether the node will participate as a validator or signer in consensus, and go ahead and click Finish. When the node has come online, we have the ability to easily connect to the node. And there's 2 routes to connect or ultimately get to the Kaleido blockchain. The first is through the native JSON RPC interface using HTTPS or WebSockets. The second approach is through a service that we've built called ETHConnect. This is a Kafka-backed messaging tier that abstracts the core JSON RPC API. So let's take a look at how ETHConnect works. First, we need to create some application credentials. These application credentials are basic auth, and they provide TLS protection when we're communicating with the node. We have 2 ways to ultimately get to this ETHConnect layer. We can use the node's webhook, or we can talk directly to Kafka, to one of the topics. Kaleido provides you with functional payloads. We have these for all of the Web3 client libraries, and we also have these functional JSON YAML payloads that can talk to the Kafka layer and ultimately resolve with the Ethereum blockchain. And this is such a valuable service because it takes the complexity out of transaction submission and communication. We see that we have a JSON payload as simple as this that will actually resolve to a properly formed Ethereum transaction object. So let's go ahead and deploy this transaction. This is a contract instantiation of this Solidity source code down here. So we can deploy it. And we're running Geth and proof of authority, so it takes 5 seconds for a block to be mined and for that transaction to get appended into the chain. Once that's done, we can check the reply on the receipts topic in Kafka, and we should see the smart contract address and all of the other fields that comprise a standard Ethereum transaction receipt. We see our contract address right here. So Kaleido makes it very, very easy to talk to the blockchain layer. The other route using the standard JSON RPC interface is going to make use of one of the common Web3 client libraries. So we see code samples for Web3 JavaScript, Java, Python, C#, and Bash. And these are functional payloads. These are functional programs here. So you can download this small node program, install the Web3 modules, and this will return you the latest block on your blockchain. Very, very straightforward. Now, it's important to know that Kaleido does not store these application credentials. These are ephemeral, meaning they're one time. Instead, Kaleido on the back end uses salt hash verification to authenticate any incoming calls to the network. So taking this username password combination, combining it with a salt, we will make sure that it creates the same hash that's been stored on Kaleido. So as we've built out Kaleido, one realization was that all of this that we're seeing right here, we can think of this as the chain layer. This is a small piece in the broader apparatus of what it takes to build a properly bona fide production caliber solution. And to accommodate that realization, we've created what we call the Kaleido Marketplace and exposed a library of ancillary chain layer services and third-party services and solutions accelerators. And rather than deploy these in the Kaleido console, let's go ahead and take a look at the Kaleido Marketplace, and we'll quickly go through these different services. So the first service is our app and integration gateway, which I just spoke to, but a picture may be more valuable than my words. And we can see the architecture right here. Think of your existing business processes as over here on the left. These are these critical pieces of software, hardened business processes that you don't want to re-architect with one of those thick Web3 client libraries. Instead, you want to simply leverage the key value pairs or the existing data, and using a simple REST interface, model your payloads as JSON or YAML, and allow this ETH-Connect layer, this Kafka-backed messaging tier, to take care of all of the Ethereum complexities: Solidity compilation, nonce management, RLP encoding, etc. And this will ultimately resolve in a properly formed Ethereum transaction. And Kafka is especially powerful here because it can accommodate for sudden bursts and surges in transaction throughput. So if you have a peak in your workload, Kafka will submit those transactions to the network at an optimal rate and provide you guaranteed delivery. The second service that we offer, which is very, very powerful in the scope of a private or permission network, is the ability to pin or tether state provenance, historical state proofs, up to one of the public networks. When we use consensus algorithms in a private network, those algorithms are reliant on private signing keys and digital signatures. So in the event that those private keys became compromised, either through collusion or through a malicious actor, it's hypothetically possible to go back in time and re-architect a chain that's not using heavy-handed proof-of-work consensus. So the tether works by having all of the nodes, all of the participants come to an agreement on the state of the network. They sign over a block number and a hash, and those agreements, those signed objects, get bundled into Ethereum transaction, and that state attestation goes up to the public Ethereum network that is protected by proof of work. Very powerful service. Every Kaleido network comes configured with 1 billion Ether in the Genesis block. So this is an out of the box allocation for token economy use cases, whether you want to charge for smart contract methods or you want to map that intrinsic token to fiat or fungible assets. You have the flexibility to use the Ether pool as you see fit. Every environment has a block explorer for granular insights into transactions, blocks, and smart contracts. We can take a quick peek back in our environment, open the block explorer, and we can see that we have a single transaction that was my deployment or instantiation of the simple storage smart contract through the ETH Connect layer. And we can see that we have a listing of the blocks that are being mined. Proof of authority consensus mines blocks every 5 seconds, as you can see. So we can look at individual blocks, we can look at individual transactions, and we can look at our currently deployed or instantiated smart contracts. One very powerful feature in Kaleido is the ability to upload source code and create a one-to-one correlation with this indecipherable bytecode or machine code, allowing for the rest of the network to see a smart contract address and then actually understand the underlying Solidity code that they're interacting with, right? Turning this bytecode into plain text or human readable source. So that's the block explorer. So we can go back to the environment and continue looking through the marketplace. The identity registry is sort of the second flavor of enterprise identity. So at the very beginning of this demo, we talked about the ability to underpin an asserted identity with an X509 certificate. You can extend that by mapping that X509 certificate to an on-chain smart contract and marrying it with an Ethereum address. And now when transactions come into the network and the from field is an indecipherable hexadecimal string, that string is actually going to resolve to one of these verified and trusted X509 certificates. So when healthcare provider ABC or bank XYZ submits a transaction, we can actually reverse lookup and map those back to one of these uploaded X509 certificates. So this provides us with enterprise identity at the on-chain layer. Pressing forward, we have IPFS. It's not economical or feasible to upload large images or files to the blockchain. Instead, you want to use a service such as IPFS to have peer-to-peer file sharing. This is censorship resistant. Every time a file gets uploaded to IPFS, it's sharded and disseminated to all the nodes. That way, on the blockchain layer, when you're using a smart contract, you simply want to reference the hash of one of the shards or the parent hash rather than using all of that data or the image. And lastly, in the scope of the ancillary chain layer services, we offer the HD wallet. And you can think of the HD wallet as a logical foil to the identity registry. Oftentimes, you want to be authoritatively identified. However, there's certain circumstances where you want to transact anonymously. It may be market intelligence for fellow members of the consortia to simply know that two organizations are transacting. So the HD wallet provides you with a limitless key tree of Ethereum addresses and their accompanying private signing keys. So you at the client side, at the application layer, you can increment through an HD wallet and you can have a different signing identity for every transaction. So those are the Kaleido ancillary chain layer services. And then we also provide a handful of partner services for solutions acceleration and streamlined application development. Unchain is a piece of middleware. Clause is very powerful for auditing. Chainlink and Rhombus are oracles, so you can configure your own customized data feeds out for real-world events, whether a payment was made, commodities prices, the result of a sporting event, weather, etc. And rather than programmatically injecting this data into a smart contract, this Oracle service can dynamically share the retrieved data with a smart contract. So this really streamlines and automates a lot of logic on chain. Open law is a framework for legal agreements, so we can use markup language and we can create our own customized legal agreements. And then when multi-parties or bilateral parties sign this legal agreement, that signature is actually an invocation of a smart contract on the blockchain layer. And the last service is Viant. Viant is a turnkey supply chain solution, business process management. So everything that I've just shown you within the scope of the Kaleido console is also accomplishable through an administrative API. So we expose admin API calls, very intuitive naming scheme for every single CRUD operation in the console. So say, for example, you want to cycle your basic auth application credentials. You can write your own automation scripts to cycle these credentials every hour, every day, every week. And this allows you to seamlessly integrate with your own business processes and your own schemes for admin consoles and lifecycle management. Everything that was done in the UI is accomplishable through the Kaleido administrative API. So we're adding new features by the day at Kaleido to provide more extensibility and more flexibility as you're building out production enterprise caliber solutions. Thanks for watching and enjoy Kaleido.